It's given that the random sample of 8 pairs of values of x and y are given in the table below, right? So you have the x and y values to be here, one pair, 4, 5, 6, 7, 8, and this last pair is actually unknown. So you think about it, they'll just form like you can actually do a scatter plot of them, right? With just the 8 crosses on the diagram. So given that the regression line for y on x, all right, is equals, okay, and x on y, for this set of data have the equations y equals to negative and so forth, respectively. We're going to find the value of x and y. So how do we go about doing this? The concept that we're going to use here is to remember that there's a particular point that actually satisfy or lies on both the regression line y on x and x on y. So do you remember, like during lecture, what's that point? Yes, yeah, that point is actually equals to x bar, y bar, right? So x bar, y bar are the 2 points that are the points that actually lie on the regression line y on x and x on y, right? So in order for us to find x8, y8, what we're going to do is we're actually going to find x bar first. We're going to find x bar and y bar first, and we're going to use these two values, right, to help us get to the unknown values, which is x8 and y8. Okay, so how do we find x bar, y bar? We know that they actually lie on the both regression lines. So simple, the idea is that we solve the two lines simultaneously. Okay, after you solve simultaneously, you can actually easily get the x bar and earlier on, y equals to negative. Alright, so quickly go to our GC. Okay, take out the, go to apps, simultaneous equation solver. Right, so you notice what I do here. This is basically nothing but keying in the two equations of the regression line y on x and x on y. So if you see the earlier on 7 over 10, this will just be me rewriting 7 over 10x plus 151 over 10. The second equation will just be equals to x negative 7 over 6y plus 20. So that's what I'm doing. I'm solving for the x bar and y bar. And so by solving, the question gives you, right, so x bar just equals to 13 and y bar equals to 6. Right, so how is that useful? How is that useful? Basically, we know that our values here, what is x bar equals to? X bar is actually nothing. X bar over here is equals to 13. But we also know that it's equals to basically the summation of x values over n. And in this case, the n is equals to 8 because there are 8 pairs of values, right? Alright, so all I'm going to do is, we know that looking at all this, alright, I can easily sum them together, alright, and that's going to, you could be writing, you could be doing it from a GC, or you could be writing like, it's equals to 10 plus 11 plus plus 12, 11 plus 17 plus 14 plus 19 plus x over 8 over 8. Right, so what's the x bar? Now you actually have an equation in where x8 is the only unknown. We know that this is x bar, then x bar just equals to 13. It's 10 plus 11 plus 12 plus 11 plus 17 plus 14 plus 19 plus x8 over 8. Alright, so solving this equation, okay, so let me just tidy up. Yeah, okay, this will look better. Okay, so solving this, x8 is just equals to 10. Similarly, for the case of y bar, we know that y bar is equals to 6. Alright, so similarly, y bar is nothing but the summation of y over n, in this case also equals to 8. Alright, so I hope you can solve it by yourself. And y bar is nothing but, if you sum up all the y values, it's 9 plus 8 plus 7, 6 plus 5 plus 4 plus 1 plus y8 divided by 8, and so y bar is equals to 6. 6 will just be, I will sum up all of these values here. Alright, this will just be equals to 40 plus y over 8 divided by 8, and y8 will be equals to 8. And there you go, we have done part 1. We have able to find the values of x8 and y8. Okay, right, so basically the idea here is that to find an unknown pair of values, we can actually use the x bar and y bar. Okay, let yi be the value obtained by substituting xi into the equation of the regression line of y onto x. Okay, for I equals to 1, 2, 8, y1 equals to -7x, y2, so on and so forth. So we need to find the value of this. Alright, so you think about it, right? First, even before we do this, what are we actually finding? So you remember we are doing a regression line here of y on x, right? The whole idea of doing this regression was that we have a pair, we have values, all right? Okay, so in the values, I'm drawing x and y axis. We are doing a regression of y on x, and this could be 10, 9, 11, 8, 12, 7. That should be x equals to 10, y equals to 9. Okay, then so they have all these 8 points, all right? Okay, so we have all these 8 points. Okay, I'm not going to label because I don't know which one is the last one. So 19, 1, maybe 19, 1. Okay, could be, maybe I wrote it wrongly. So let me just put it here. Maybe it could be 19, 1. So this one could be maybe 19, 1. This could be probably 10, 9, some sort. Okay, so these are all the points that we have, okay, from the data values over here. So what does this capital Y1 and capital Y2 mean? Remember, the whole idea was that with all these points, we are trying to draw a regression line. Okay, this regression line is the one. Okay, so this regression line, based on the calculation, I mean, just imagine in this scenario, is actually is the y equals to -7 over 10 x plus 151 over 10. This is the regression line that we have gotten. Okay, so y1, what is the original y? The y1 is the original. This is probably the original y1 value here, right? So if I were to look at this, right, this is probably the original y1 value here. This capital yi refers to, for this x value, all right, remember this is probably your x1, y1, correct? So this will actually be finding the y1 value. So when we look at this difference, right, when we look at this difference here, right, where's the capital Y1? The capital Y1 actually, this is like x1 and capital Y1. Right, because capital Y1 is the y coordinate of the point on the regression line. Based on this, okay, based on this regression line. All right, for this value of x1, we put the x1 in, x1 equals to 10. This is the value of capital Y1, right? So what are we doing? We're actually finding all the differences here, the sum of all the differences. This is the, okay, so this is basically the, if you think about it, this is the, like, the adding, the summation of y1 minus capital Y1, y2 minus capital Y2. And what is 1 capital Y? This is basically y1, the y value of this point, right? This point here, y3 is over here, capital Y3, capital Y4, capital Y5. Okay, so capital Y is the output from the original x1, x1, x2, x3, but onto the regression line. Alright, small y1, small y2, small y3 are the original scatter plots over here. So each time we're doing a summation, this is cell, I mean, this would be like it could be y2, this is like the, if we talk about the blue portion, is like the absolute difference, right, between small y2 and big y2, right? So basically, if I were to look at this point, this is like x2 capital Y2, and this point will be x2 y2, right? So over here, maybe I just look at I just pick another point just to make it clear to you. This point here could be x4 capital Y4, right? And this point here would be x4 small y4, right? So those in black are the points that are originally plotted by the scatter plot, and those in red are the, okay, that's a regression line. So what are we minimizing? We are trying to minimize all the blue color lines over here. Alright, so if you actually read your notes, if you read your notes, right, you read your notes, you know that in the notes they call it E1, E2, E3, E4. So it's like we're minimizing all the errors, right? Okay, E1, E2, we call it errors, and that's the line of best fit. That's what we're going to do. They're trying to minimize the errors, right? So this is the line of best fit. That means, right, any other line, regression line, will not give a line as good as this, right? So we will do find the value of this. Right, so how do we go about doing it? So this means that back to our original question, the summation of 8y1 yi minus capital Yi square is equals to 8.8. Okay? Alright, so next part, let's look at this portion. Is there any inequality that must be satisfied by 8 of yi minus a minus bxi for any real constants a and b? So what does this actually really look like on the diagram? Remember that by doing regression, we are already finding the line of best fit that minimizes all the errors, right? Okay, between, they already minimize all the sum of the square of the deviation. Yeah, the sum of the square of the deviation of each value of y in a data set form. Right? So how do we justify this answer? Okay, so remember that we in the regression we were already do. So what this question is asking is that is any a and b. That means, right, our original here they are talking about here. This is another. This is as though they are saying another capital yi, right, for any real constants a and b. So what will be the inequality? So remember just now, while we were doing the summation of I equals to yi minus yi squared, this was equals to 8.8, done in part 2. Alright, and this is actually basically the this is already the minimized sum of the squares of the deviations, right, of each value of y, right, in the data set from the value of y attained by the regression line. Alright, this is already the minimized sum, because remember the line of best fit serves to do this, right? Already found that. So if you are not sure, let me just check again. It looks like this, right? Remember our point here could be something like this is your xi yi, alright, and then somehow somewhere we have formed a regression line, but over here, right, this would be xi and capital Yi. Alright, so capital Yi, right, and then what your regression, the summation serves to do is actually is already the minimize form. They are trying to minimize this error, right, and this is the original your regression line. Alright, so unless we are talking about the line of best fit, so only this regression line gives you, right, the minimum distance or the minimum sum. So only if I have this regression line, right, basically this is kept to a minimum. Any other line will not give you a minimum. Okay, this sum here, if you add up, so presenting you to a solution, the least squares, right, okay, of y on x, as the name suggests, minimizes the sum of the squares of the deviation of each y value in the data set from the value of y attained, right, for the same value of x, like if you saw how I showed it in the diagram earlier. So the sum of squares for the same data set with respect to any other straight line must be larger. Okay, so basically, right, just now we have already found